Let's look at Newton's third law of action problems, and we'll look at the action-reaction for two different objects. First, let's review. Let's talk about Newton's second law. Newton's second law deals with the relationship between force, mass, and acceleration. And we know that force equals mass times acceleration. When we talk about Newton's third law, it states that for every action, there is an equal and opposite reaction. And we call the objects that are in that interaction an action-reaction pair. Now, when we talk about an action-reaction pair, the force exerted on the action is equal to the force exerted by the reaction. So let's look at two objects. Let's say that we've got a rifle and a bullet, and we fire the bullet by the rifle. The bullet is going to exert a force on the rifle, and the rifle is going to exert a force on the bullet. The forces are equal and opposite. So this part of the equation is the same. But the mass of the bullet and the mass of the rifle are different. And because the masses are different, the accelerations are going to be different. So if we look at Newton's second law and we manipulate it to solve for acceleration, acceleration equals force divided by mass. Now in that equation, and with an action-reaction force pair, the force is the same. So this value here and this value here are going to be the same for the bullet and the rifle. But the mass of the bullet is different than the mass of the rifle. The mass of the bullet is very small relative to the mass of the rifle, which is very big. Now in turn, since the bullet has a small mass, its acceleration is going to be fairly large. Now on the rifle side of this interaction, the mass is relatively big, which is going to make the acceleration of the rifle very small. So the smaller the mass of an action-reaction force pair, the larger the acceleration, and the opposite, the larger the mass of an action-reaction force pair, the smaller the acceleration. Why don't action and reaction forces cancel? In some cases, when the interaction is between a system, something we're looking at, and something external to that system, the action and reaction forces don't cancel. So if the interaction is between the system and something external, or something outside the system, forces cancel, or forces do not cancel. But if the interaction between two forces is within the system, then the net force is zero. So if the interaction is between objects in the system, the net force is 0. So let's look at an example to try and explain this. If we look at the first one, we have a foot interacting with the ball. So our action is the foot on the ball. The reaction is going to be the ball on the foot. But in this case, our system is the ball, and the foot is something external to that system. So when the foot acts on the ball, it's going to cause the ball to accelerate. And when the ball accelerates, that means our net force is not 0. If we look at the second example, let's say that we've got a person kicking the ball from the left, and we have a second person kicking the ball from the right. In this case, there are two forces acting on the ball. Those forces are equal and opposite, so the net force on the ball is 0. But not for the single interaction with one foot. So if we were to look at the left foot kicking the ball, the net force would not be 0 because the ball would accelerate without the second foot. And if we were to look at the foot from the left kicking the ball without the foot on the right, the ball would accelerate. But since we've got two forces acting on the ball in equal and opposite directions, the net force on the ball is 0. And the ball does not accelerate. So think about this. If you kick a ball, it will accelerate. Does this acceleration contradict Newton's third law? No, it doesn't. Your kick acts on the ball. No other force has been applied to the ball. The net force on the ball is very real, and the ball accelerates. What about the reaction force? Well, that force doesn't act on the ball, it acts on your foot. The reaction force decelerates your foot as it makes contact with the ball. You can't cancel out a force on a ball with a force on your foot.